Action.
Alright, more oxidation numbers stuff. So today we're going to talk about, if we have individual elements, we're going to talk about polyatomic ions. So, the first one here, the oxidation number of atoms in a pure element is 0. So what I mean is, some elements we don't find individual atoms. We find that they come in pairs of 2, or sometimes sulfur will be found as 8 atoms stuck together, and so on, right? Fluorine, chlorine, bromine, oxygen, a lot of the gases are diatomics. There's always 2 of them. And so what that means is, since they're both the same, they're both going to have the same oxidation number, which will be 0. So if you have, like, let's start out with something simple. If you just have iron metal, right? Plain iron metal, the oxidation number has to be 0. It's not with anything else. It doesn't have a charge, so it doesn't have an oxidation number. Well, things could have an oxidation number if they don't have a charge. Let's say we have O2 gas, right? Well, there's 2 oxygens. One's not going to have a different number from the other, right? So both of them have an oxidation number of 0. So anything like that. Sulfur, S8, all the sulfurs are going to have an oxidation number of 0. So in an element, they're all 0. All right. All right, the other thing, the oxidation numbers for elements in a polyatomic the oxidation numbers for the elements in a polyatomic ion. All right, so what do they have to add up to? Somebody who's really awake and understands what's going on today. What do you think?
0.
Wasn't looking for you. No, think about it. Polyatomic ions have a charge, right? So the oxidation numbers have to add up to the charge of that polyatomic ion.
That was recorded, by the way.
I know. That's okay. Jeff Smith from Colorado. Okay, you guys didn't get that. All right, so let's look at hydrogen phosphate, for example, which I think is going to be -2 there, right? So it has a charge of -2. So if we add up all of the oxidation numbers in here, we should end up with a -2, right? So basically, here's how I'm going to write this out. I'm going to write H and P and 4 oxygens, right? 4 O's. It's going to add up to -2. Really, usually it would be 0, but this is a polyatomic. Well, oxygen is what? Now's your time, Mohammed.
-2.
-2. 4 times -2. So that's oxygen, right? And the hydrogen, what's hydrogen? +1. And so whatever the P is has to make up the difference, right? So we got 1 plus P plus, that's -8. Oops, -8. Let's put not plus negative, which is -2. Equals -2. All right, so
5.
the 1 and the 8 make it -7, right? So P -7 equals -2. If we add 7 to both sides, we end up with phosphorus and oxidation number of +5. So if you put 5 in here, we should end up with -2. So that's what you got to do. You add together all the charges, whatever one is left, you got to solve for it. And it has to add up to the oxygen, to the charge of that polyatomic. Let me do another one of those.
Just one more.
All right. So let's do nitrate, NO3, and this is -1, right? Nitrate's -1. That sounds right. All right. So N plus Oxygen's always -2, right? That doesn't change. So 3 times -2 has to equal -1. So N -6 equals -1. We add 6 to both sides. Oddly enough, this one also comes up to +5. I didn't plan it down. You good with that?
Yep.
All right, we are done. We are done for the year. Chemistry is over. Well, after you finish this worksheet, we'll be. And unless I find it close to it.
That would
He would do that.
No.
Yeah, there's a lot more to do with these oxidation numbers, but it's June. Not a good time to write down a worksheet. She's in a bad mood. Do you want to tell her, Mohammed?
Oh, I'm not in a bad mood. I'm in a great mood.
Just get your system moved real quick because the camera's still on.
Thank you.
You're welcome.